Hello and welcome to the third and final video in our Year 9 coordinate geometry series. Today we'll be looking at finding the equation of a line. So that will be sort of putting together the stuff we've learned in the previous two videos. Now this is quite a long video, might have to break it up into multiple parts, but we'll see how we go. So let's quickly do a recap of the things we've covered in the last two videos. With this line on the right-hand side, we can see we've been asked three questions. Number one, what is its gradient? Number two, what is its y-intercept? And number three, what is its x-intercept? So for its gradient, remember, we can think about it as either rise over run, or we can use our formula, which is y2 minus y1 over x2 minus x1. For this specific example, I'm going to show you both ways just to refresh your memory. So if we want to do rise over run, I have to choose 2 points, and then I need to examine the rise and the run. So you can see the rise here is going to be 4 units, okay? We're going up by 4 units, so it's positive. Our run, you can see we're going across by 2 units, so plus 2 units. So you can see our rise over run is going to be 4 over 2, which is equal to 2. Now, if we were to use our formula, we would let this point, you can see this coordinate is 0, 4. You can see that this coordinate here is 2, 0. So if we were to use our formula, which is y2 minus y1 over x2 minus x1, then we can just plug in the numbers. So we'll let this be x1, y1, and we'll call this x2, y2. So remember, just need to be consistent with it. So y2 minus y1, you can say it will be 0 minus 4 over 0 minus 2, and that's equal to negative 4 over negative 2, which is equal to 2 units. Now, part 2. What is its y-intercept? Well, remember, the y-intercept is where a line crosses the y-axis, and you can see it crosses the y-axis at a point of 4. So our y-intercept is 4. And third question, what is its x-intercept? Well, you can see our line crosses the x-axis at a number of 2. So that's going to be our x-intercept. X equals 2. So hopefully that is a small recap and it helps you remember the stuff we've covered in the previous two videos. So let's talk about gradient-intercept form. The equation of a line is usually expressed in one of two forms. So the most intuitive, I think, is going to be the gradient-intercept form. So the gradient-intercept form is y equals mx plus b, where m is the gradient and b is the y-intercept. This means that if we can find the gradient and the y-intercept of a line, we can actually directly say what its equation is. So let's write the equation of the line on the right. Well, we know what? We know that our gradient is equal to 2. And we know that our y-intercept, so we're going to use b in this case. You might see some textbooks have y equals mx plus c, but it really does not matter what this letter is. So b here is going to be 4. And so we can say that y is equal to 2x plus 4. Now, I think it's really important to understand what an equation tells us. It gives us a relationship between y and x here. So this is saying that y is equal to 2x plus 4. And if I was to break that down into English, it means y is equal to 2 times x plus 4. So given an x value, if you double it, then add 4 to it, you should get the y coordinate. Let's test that out for a couple points so that it makes sense. So if I was to choose the x coordinate of 0, if I double that, so 2 times 0 plus 4, I'm going to get 4, right? So you can see that that is exactly what our coordinate is. Our coordinate is 0, 4. How about, let's say 2? If I sub in x equals 2, I'm going to get, sorry, negative 2. This is negative 2. So if I do 2 times negative 2 plus 4, well, 2 times negative 2 is negative 4, plus 4 is 0. You can see that is specifically the coordinate we have here. It's negative 2, 0. So hopefully that makes sense. Now, let's talk about general form. General form is a bit more interesting in that the formula is ax plus by plus c equals 0. It is important to understand that b here is not necessarily the same as this b here. They're actually different. So a, b, and c are real numbers, and this is something that students always forget. In general form, a has to be greater than 0. Okay? So note that it is possible to switch between general form and gradient intercept form by simply rearranging the equation. So in the previous one, remember how we got y equals 2x plus 4? If I was to convert this into general form, all I would do is move the y to the other side, because remember, general form has to equal to 0. So if I move the y to the other side, I get 2x plus 4 minus y is equal to 0. I'm just going to rewrite this so that it follows the same pattern here. So 2x minus y plus 4 equals 0. And you can see now that this is basically general form. We have 2 as our a value, and that is positive, so it's okay. Note that if I had moved everything to the left-hand side, right? So if I moved everything to the left-hand side, I would have got minus 2x and minus 4 equals 0. And then I've got minus 2x plus y minus 4 equals 0. So all I've done is just flip them around, like change them around in order. This is not general form. And the reason for that is this. The coefficient of x, which is a, is negative 2 here, which is not greater than 0. So hopefully that makes sense. Let's move on. So here we have an example. Consider a line passing through the points 3, 7, and 0, negative 2. Part 1, find the gradient. Part 2, write the equation. And part 3, write the equation in general form. So let's plot out what we've got. So we've got 3, 7. So that would be about here-ish. And we've got 0, negative 2. So 0, negative 2 is here-ish. There we go. So that's our second point. Okay. I'm just going to do a crappy job of just drawing out the line. So hopefully that makes sense there. Now, part 1, find the gradient. Obviously, I'm not going to count the rise over run. I've been given the 2 coordinates, so it makes sense to just chuck it into my formula. So I'll call this x1, I'll call this y1, and I'll call this x2, and I'll call this y2. So then y2 minus y1 is minus 2 minus 7 over 0 minus 3. That's going to give me negative 9 on negative 3, which is 3 units. So that's my gradient. Write the equation of the line in gradient-intercept form. So remember, for gradient-intercept form, it's y equals mx plus b. I need the y-intercept. Do I have the y-intercept? Yes, I do. The y-intercept is negative 2. So I can say that y is equal to 3x plus negative 2. So just minus 2. So hopefully that makes sense. And then for part 3, which is write the equation in general form, remember we have to move everything to one side and make sure that the coefficient of x is greater than 0. Here we already have a coefficient of x greater than 0, so it makes sense to just move the y to the other side. So we have 0 is equal to 3x minus y, because I moved it to the other side, minus 2, and that's it. So that is my general form. Hopefully that makes sense. Now we have the point gradient form. So the point gradient form is basically given one point and a gradient of a line, we can find the equation of that line. So here's an example. Find the equation of the line with gradient 1 passing through the point 1, 0. So we know that it passes through 1, 0, which is this point here, and it has a gradient of 1. So it looks like this. Now, how do we find the equation of this line? Well, if we are to use the point gradient form, we just need to know one point and we need to know the gradient. Thankfully, we know that m is 1 because it says in the question. And we can say that x1, y1 is equal to 1, 0. So therefore, we can just directly substitute this back into the equation and see what we get. So let's see. We've got y minus y1. So y1 is 0 here. So 0 is equal to m which is 1, so just 1 here, bracket x minus x1. And x1 is going to be, in this case, 1. So we have y is equal to x minus 1, and that is our equation of this line. Now, let's go through another example. Find the equation of a line passing through the points 4, 2, and 5, 1. So here, we don't have the y-intercept. But what can we do? We can use our point gradient form, okay? So point gradient form, remember that was y minus y1 is equal to m x minus x1. So what do? We need to first figure out the gradient. So let's do that. So m is equal to y2 minus y1 over x2 minus x1. I'm just going to label this as x1, y1, x2, y2. So that means it's going to be 1 minus 2 over x2, so 5 minus 4. And that's going to be negative 1 on 1, so negative 1. Then we need to use 1 point. So here we've been given 2 points. But the thing is, we have both those points have to lie on the same line. So it doesn't matter which one we use. In fact, for this example, I'm going to show you how, regardless of which point I sub into this equation, I will end up getting the same answer. So let's first use this point. So if we have y minus y1, that'll be y minus 2 is equal to negative 1 x minus 4. So y minus 2 is equal to negative x plus 4. And that means y is equal to negative x plus 6. Now, had I used the other coordinate, then I would have got y minus 1 is equal to negative 1 x minus 5. So that means y minus 1 is equal to negative x plus 5. And that means y is equal to negative x plus 6, because I've moved the negative 1 and becomes a plus 1. So you can see you get the same answer regardless of which point you put into the point gradient form. But as long as we found a gradient and we have a point that lies on the line, we can find the equation of a line. So hopefully that makes sense. Now, in the previous example, we did use the point gradient form, but there is a specific formula which we can use where we've been given 2 points. So this is called the 2-point formula. So if you've been given 2 points, you can use this formula to figure out the equation of a line. So by substituting the gradient equation m equals y2 minus y1 over x2 minus x1, we get y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1, which is now going to be our 2-point formula. So let's actually put this into practice. Find the equation of a line passing through the point 4, 2 and 5, 1 using the 2-point formula. Now, in this question, it specifies that we have to use the 2-point formula. So I'm going to show you how to do that. But in my experience, it's much easier to just find the gradient and use the point gradient form than it is to use the 2-point form. But let's just use that. So here we have our equation, y minus y1 equals, so let's just write that down, y minus y1 is equal to y2 minus y1 over x2 minus x1 bracket x minus x1. So if we let this be x1, y1, and we let this be x2, y2, then we can sub everything in. So y minus y1, so y1 is 2, is equal to y2 minus y1. So that's going to be 1 minus 2. x2 minus x1 is going to be 5 minus 4. And x minus x1 is going to be x minus 4. So now we get y minus 2 is equal to 1 minus 2 is negative 1. So negative 1 is our numerator. 5 minus 4 is 1. So negative 1 over 1. So I'll just write that like that. And then we've got x minus 4. So y minus 2 is equal to, that's just negative 1. So negative 1 x minus 4. Then we keep going. So we get y minus 2 is equal to negative x plus 4. And so y is equal to negative x plus 6. And that is going to be our final answer. And you can see that it correlates with the answer we got from the previous question as well. So using the line equation, given a line equation, general or gradient form, we can find points on the line by subbing in either x or y. So let's consider the line y equals negative 3x plus 4. Find, number one, any point on the line. So if asked for any point on the line, you can sub in any x value or any y value you want, and you'll get the coordinates. So for this one, I'm just going to sub in let x equal 0. So if I sub in x equals 0, then my y value is going to be negative 3 times 0, which is 0, plus 4, so 4. So that means I get the coordinate of 0, 4. So 0, 4. That is going to be a coordinate on my line. Part B, find the y-intercept. So I've actually unintentionally done that. But the point is, for y-intercept, you sub or let x equal 0. Okay? Because the y-intercept lies on the y-axis. And what is the equation of the y-axis? Well, the equation of the y-axis is x equals 0. And if that doesn't make sense, please refer to our first video in this series. And part C, find the x-intercept. So to find the x-intercept, we always let y equal 0. And the reason for that is, once again, the x-intercept lies on the x-axis. And the equation of the x-axis is y equals 0. So if I let y equal 0 in this equation here, I get 0 is equal to negative 3x plus 4. That means I get 3x is equal to 4. So I'll just move that minus 3x to the other side. And therefore, I get x is equal to 4 over 3. And that's about, what, 1 1/3. So around here, 4 over 3. So part D, plot the line on a graph. So you can see I've been given 2 points, so I can easily join them together and plot my graph. So that is what it looks like. Hopefully that makes sense. Now, given the equation of the line, the easiest way to plot the line is to find 2 points, right? And the easiest 2 points to find would be our x and y intercept. So here we've been given a line. You can see this is in general form because we have an ax plus by plus c equals 0, and that first number is positive. So question is, let's plot the line. So let's find our x-intercept and our y-intercept, plot those, and then we have our line, right? Remember, a line is defined by 2 points or 1 point and a gradient. So to find my x-intercept, remember, I have to let y equal 0. So if I let y equal 0 in this equation, I get 3x minus 4 times 0, so 4 times 0, minus 8 is equal to 0. So 3x minus 0, so minus 8 is equal to 0. 3x is equal to 8, and x is equal to 8 over 3. To find my y-intercept, I would let x equal 0. So let x equal 0. So to do that, I get 3 times 0 minus 4y minus 8 is equal to 0. That means I've got minus 4y minus 8 is equal to 0. And that means negative 8 is equal to 4y. And so y is equal to negative 8 divided by 4, which is negative 2. So an x-intercept of 8 over 3. So that's going to be approximately here-ish. So that's 8 over 3. This point here. I'll call that 1. That would be about 2. That's 0. And our y-intercept is negative 2. So that's negative 1. That's negative 2. So you can see we have a point here and a point here. If we just join those together, we have the equation of our line. So hopefully that makes sense in terms of like how we've got our equation and then translating that into an actual line on a coordinate plane. Let's go through another example. Consider the line 2x minus 5y minus 7, sketch its graph and find its gradient. So, quite simply, find the x-intercept, find the y-intercept. Those are our two easiest points to find. So, for our x-intercept, I let y equal 0. So that means 2x minus 7 equals 0. Hopefully that did make sense because I did skip a step there. So obviously if I'm letting y equal 0, this whole thing goes away. So it's just 2x minus 7. So 2x minus 7 equals 0. So 2x is equal to 7. And that means x is equal to 7 over 2 or 3.5. For y-intercept, I let my x equals 0. So I get minus 5y minus 7 is equal to 0. So that means minus 5y is equal to 7. And that means y is equal to 7 over negative 5. So if I plot those points together, x-intercept of 7 on 2 and a y-intercept of 7 on negative 5, about here, I've got my 2 points. Now, I've sketched the graph by joining them together, but this question asks for something else. It asks for its gradient. Now, there's two ways of doing this. You can either use the 2 points, so the x and y intercept, to find the gradient, or you could convert this back into point gradient form. Sorry, gradient intercept form. So how do we do that? Well, we need to make y the subject, okay? So we've got 2x minus 5y minus 7 is equal to 0. So that means 2x minus 7 is equal to 5y. I'm just going to write that as 5y is equal to 2x minus 7. It's normally y equals something. So then if we divide everything by 5, we get y is equal to 2 over 5 times x minus 7 over 5. So our gradient, you can see this is in gradient intercept form. So gradient and intercept. So our gradient here is going to be 2 over 5. And that makes sense because if you look at this line, it's relatively flat. It doesn't have a gradient of greater than 1. So hopefully you can see how we can use gradient intercept form and convert between that and general form to find the information we're looking for. So here's another example. Find the equation of the line. So you've been given this point here, which is 3, 0, 0, 3. And you've been given this point here, which is 6, 0. So how do we find the equation? Well, you can either use 2-point form, but I'm not a big fan of that. So we're going to use point gradient form. How do we do that? Well, we need to find the gradient first. So the gradient, we use our formula. It's equal to, I'm not going to show you like labeling x1, y1. Hopefully that makes sense by now anyway. So you'll just do 0 minus 3 over 6 minus 0. That's equal to negative 3 on 6, which is equal to negative a half. Then I'm just going to sub it into my point gradient form, which is y minus y1 equals m x minus x1. So y, I'm going to use this point here. So y minus 0 equals negative a half x minus 6. So y is equal to negative a half x plus 3. So that is our answer in gradient intercept form. Now let's talk about parallel and perpendicular lines. So if two lines are parallel, they have to have the same gradient. And if two lines are perpendicular, then the product of their gradients is -1. So let's consider this below example, okay? We have the line y equals 2x plus 4. So instantly we know that this is in gradient intercept form. And so we can quote a few things. We can say that the gradient m is equal to 2. And we can say that the y-intercept is equal to 4. So now, part A, show that 6x minus 3y plus 1 equals 0 is parallel to the line. So what we're trying to do is trying to show that it has the same gradient. Now, how on earth do we show that? Well, the first step to doing that is going to be converting this to gradient intercept form. So let's do that. First, we go make y the subject. So we have 6x minus 3y plus 1 equals 0, which means 6x plus 1 equals 3y. So I've just moved the 3y to the other side and then flipped the equation. And that means y is equal to 6x over 3 plus 1 over 3. So y is equal to 2x plus 1 on 3. So you can see that the gradient here is also 2. So that makes sense. Now for part B, show that x plus 2y plus 7 equals 0 is perpendicular to the line. So we're going to be doing the exact same thing, but hopefully we get a different gradient so that the new gradient times 2 gives us -1. So let's have a go. So we have x plus 2y plus 7 equals 0, which means 2y is equal to -x, -7, which means y is equal to -1 over 2x minus 7 over 2, which means our gradient here, I'm going to call this m1. So that means m2, our second gradient, is a -1/2. Now let's double check if these two gradients actually multiply to give us -1. So m1 times m2 is equal to -1/2 times 2, which is equal to -1. So therefore, we can conclude that the two lines are indeed perpendicular. So here's another example. Find the equation of the line parallel to this line and passing through 1, -5. So have a go at this question, pause the video, and then we'll go through the solution together. Okay, so hopefully by attempting this question, you've realized you need to use the point gradient form. And why is that? Because we have a point, and from here, we can actually figure out the gradient. Because we can find out the gradient of this line, and the equation of our line, it says it's parallel, right? So parallel means our line has to have the same gradient as this line. So let's first figure out what this gradient is. And how do we do that? Well, we need to convert the general form into point gradient form. So that means we have 2x minus y minus 3 equals 0. So if I make y the subject, y is equal to 2x minus 3. So that means gradient is equal to 2. So that means my gradient is also equal to 2. So if we use the point gradient form now, y minus y1 is equal to m x minus x1, we can simply figure out the equation. We can say y minus -5 is equal to m, so 2, and x minus 1. So that means y plus 5 equals 2x minus 2, which means y is equal to 2x minus 7. And that is our final answer. Here's another example. Given the lines 4x minus 3y plus 2 equals 0 and kx minus 5y plus 1 equals 0 are perpendicular, find the value of k. So first what we should do is find the gradient of each line and then let them multiply by each other and equal -1, right? Because that's the definition of what perpendicular lines are. So for this line, our equation, we have 4x minus 3y plus 2 equals 0. That means 3y is equal to 4x plus 2. That means y is equal to 4 on 3, x plus 2 on 3. And so our gradient is equal to 4 on 3. For the next one, we have kx minus 5y plus 1 equals 0. And it might be a bit odd that we've got a k here, but just treat it like a number, just like any old pronumeral. So if we make y the subject, well, that means 5y is equal to kx plus 1. Hopefully you can see I've just moved the -5y to the other side, which means y is equal to k over 5 x plus 1 over 5. So our gradient here, I'll call this m1, by the way. So that means m2 is equal to k over 5. Now, we've been told that these two lines are perpendicular, which means m1 times m2 has to equal -1. So using that into fruition, we can say that we have 4 on 3 times k on 5 is equal to -1, which means 4k on 15 is equal to -1, which means 4k is equal to -15. And I'm running out of space, so I'll just move over here. But if 4k is equal to -15, well, that means k would have to equal -15 over 4. So hopefully that makes sense. Now we need to talk about the intersection of lines. So given the lines 2x minus 3y minus 3 equals 0 and 5x minus 2y minus 13 equals 0, find their point of intersection. So with intersections, the point of intersection is basically a coordinate which satisfies both lines. So if I have one line here and I have another line here, well, this coordinate lies on both lines, right? That is the point of intersection, which means if I sub in the x and y value for that coordinate, it should satisfy the equations of both lines. So how do we go about this? Well, the hint is that you should use your knowledge from simultaneous equations, and that's perfectly it. If you need to find the intersection between two straight lines, you need to use simultaneous equations and solve for x and y. So let's write that down. 2x minus 3y minus 3 equals 0. I'm just going to write that as 2x minus 3y equals 3. So I'll call that equation 1. And then similar thing here, I'm just going to write 5x minus 2y is equal to 13. So I've just moved the -13 to the other side. So I'll call this equation 1 and call this equation 2. Now, to solve this simultaneously, we can either use substitution or elimination. I'm a huge advocate of the elimination method. So for this specific one, let's multiply the first equation by 5 and multiply the second equation by 2. So that way we get the same x's. So that means I'm going to get 10x minus 15y equals 15. So that's equation, we'll call this equation 3 now. And then 10x minus 4y equals 26. We'll call that equation 4. And then I'm going to do equation 3 minus equation 4. So 10x minus 10x, they cancel each other out. Negative 15y, so negative 15y minus 4y is equal to 15 minus 26. So negative 15y minus 4y is negative 11y, and 15 minus 26 is equal to negative 11. So that means y is equal to 1. And then using that logic, we can sub that into any one of these to figure out what x is. So let's sub it into equation 1. So if 2x minus 3y, now remember y is 1. So it's 2x minus 3 is equal to 3. That means 2x is equal to 6. And that means x is equal to 3. So x equals 3. So in terms of what does that mean? Well, it means our coordinate of intersection, so this point here, is equal to the coordinate 3, 1, because x equals 3 and y equals 1. So hopefully that makes sense. Let's go through an example. Part A. Find the intersection between the lines 3x minus y plus 1 equals 0 and x plus 2y plus 12 equals 0. And part B, show that the lines are concurrent to 4x minus 3y minus 7 equals 0. So let's handle part A first and then talk about part B. So part A, we just use simultaneous equations again. So 3x minus y equals negative 1. And we have x plus 2y equals negative 12. Elimination again, so I'm going to double the top equation. So I get 6x minus 2y equals negative 2. So I'll call that was equation 1, that was equation 2. This is equation 3. And you can see if I add equation 2 with equation 3, I can cancel out the y's. Now, if simultaneous equations are a bit confusing for you, do check out our videos on that topic. We cover both substitution and elimination. So if I'm adding equation 2 and 3, x plus 6x is 7x, 2y plus negative 2y is, well, they cancel out. That's the whole point of this. And that's equal to negative 12 plus negative 2, which is negative 14, which means x is equal to negative 2. And if we sub that into any one of these, I'm going to sub it into the first one. So 3 times negative 2 minus y equals negative 1. That's negative 6 minus y equals negative 1. So negative y equals negative 1 plus 6. So negative y equals 5. So that means y is equal to negative 5. So therefore, our point of intersection is negative 2, negative 5. Now, to show that the lines are concurrent, what that means is so right now we've got an intersection, right? Now, if this line is concurrent to those two lines, it means that it also passes through this intersection point. Now, how do we know if a line passes through a point? Remember, if you sub in the point into the line equation, it should satisfy the equation. So if we substitute x equals negative 2 and y equals negative 5 into this equation and it works, that means that this line also passes through the point of intersection. And so you can say the three lines are concurrent. So let's quickly prove that. 4 times x was negative 2, so 4 times negative 2 minus 3 times negative 5 minus 7. Apologies for the crowdedness here, but you can see 4 times negative 2 is negative 8. Negative 3 times negative 5 is positive 15. And we have negative 7. And that does equal 0 because you can see negative 8 plus 15 plus, minus 7. Well, these are negative 15 plus 15 equals 0. So yes, the lines are concurrent. Here's another example. A company manufactures cables for 50 cents each with fixed costs of $1,000 every week. The company sells the cables for $2 each. So part A, find the equation for the revenue in terms of X cables a week. So it says the company manufactures for 50 cents each with fixed costs of $1,000 every week. The company sells the cables for $2 each. So for I, which is supposed to stand for revenue here, that would simply be $2 times X cables. So 2X, right? Because each cable we're selling for $2 and we have X cables. So 2X would be our revenue. That's how much we are selling for. For part B, find an equation for the cost, so C, in terms of X cables a week. Well, we have a guaranteed cost of $1,000, right? So we have 1,000 guaranteed cost, and then it's going to be 50 cents per cable. So that's going to be 0.5 times the number of cables, so 0.5x. So part C is find the break-even point. Obviously, breaking even means your cost is just equal to your revenue. So if we want to let that happen, so we say I is equal to our cost. So in this case, we're going to say I minus C equals 0. So 2x minus 1,000 plus 0.5x equals 0, which means 2x minus 0.5x is 1.5x minus 1,000 is equal to 0. And then x is equal to 1,000 over 1.5. And that is roughly equal to 666.67. So in terms of finding the break-even point, we would say it's 667 cables per week. And part D, find the profit on 2,000 cables. Well, remember, profit is going to be our revenue minus our cost. So that's this equation right here. Now, if we have 2,000 cables, well, we just let x equal 2,000 and sub it into here. So we have 1.5 times 2,000 minus 1,000, and that is equal to 3,000 minus 1,000, which is equal to $2,000. So the profit made on 2,000 cables happens to be $2,000. Let's talk about some special cases of lines. So far, we've discussed lines with non-zero slopes. Now let's consider lines that are horizontal or vertical. So question 1, what is the gradient of a horizontal line? We've already actually covered this in our gradient and slope video. That is going to be a gradient of 0 for a horizontal line. What is the gradient of a vertical line? Well, we already discovered that as well. It's undefined because our gradient is defined as rise over run. And so for a vertical line, it doesn't actually have a run. So we would have a denominator of 0, and obviously you can't divide by 0. So that would be a undefined gradient. And part 3, write the equation for the horizontal and vertical lines passing through the point 2, 3. So here is the point 2, 3. So for the horizontal line passing through that point, the equation is simply y equals 3. Because you can see every single point along this line has a y coordinate of 3. And for the vertical line passing through, that has an equation of x equals 2. Because every point along this line has an x coordinate of 2. So for all horizontal lines, it's y equals something. And for all vertical lines, it's x equals something. So hopefully that all makes sense. And that brings us to the end of our Year 9 coordinate geometry series. Hopefully all the different cases here made sense, and this was a very long video. So do make sure to check out our homework video, which will sort of consolidate all the theory and all the concepts we've learned in this whole topic so far. So make sure to check that out, and we'll see you there.